Okay, so now that we've looked at a graphical and how to write limits and how to read them and how to evaluate them from a graph, we want to learn how to evaluate them algebraically, which is kind of the fun part. But to start with, we'll start real slow. And when we do these, we normally begin, and for now, we'll just look at the two-sided limit. Okay, so for now, to start with, we look at the two-sided limit. Later on, when we look at maybe vertical asymptotes and things, it might be worthwhile to look at a one-sided limit. But for general, we want to start with these two-sided limits. And now most limits, if you think about most points on the curve, have a limit, correct? Because they're just points on the curve and the curve's continuous and you have a limit. So for most of them, always our first step, always we begin by trying direct substitution, which is exactly what it sounds like. You take the limit, whatever x is approaching, you put it in for all the x's, and you evaluate it. Okay. There's a couple of answers that we get that we can't deal with that we have to look further. But for example, if we just are asked to determine the limit, where did I put that? I had a nice one here. There's one here. Of x approaches 2 of x squared plus 5x plus 6 over x plus 2. Now, if we're asked to evaluate this, if you look at it, you probably think, hey, this is some sort of rational function, right? And we'll investigate and see what happens. But to evaluate this limit, the first thing I'm going to try, and this is the first thing you try every time, no matter how many neat techniques we learn, is you just try direct substitution. Okay, so to try direct substitution, I'm going to not write the limit. So once you substitute, you want to quit writing the limit. But as long as you're doing any algebra where the limit's there, well, we need to leave the limit there. So I'm going to say 2 squared plus 5 times 2 plus 6 over 2 plus 2. So as we evaluate this, we get 20 over 4, and that gives us 5. So we just determined that the limit as x approaches 2 of x squared plus 5x plus 6 over x plus 2, write the whole thing out, is equal to 5. So that's direct substitution. That's always the first thing we're going to look for. Okay. You know, if you had 0 divided by 4, the limit would be 0 because we can divide by that. Okay. Where things kind of get interesting and we have to be a little more creative is when we try direct substitution and we don't get a nice answer like this. Okay? And the one that we're most concerned about is if direct substitution gives us 0 divided by 0. Right? This is what's called an indeterminate form. And what that means is we know, hopefully we've known for a long time, if I take 0 and divide it by anything, I get 0, correct? But if I take anything and divide it by 0, I get undefined. So is this 0 or is it undefined? Well, we don't know. It's indeterminate. Right? Both of our rules kind of clash with each other there. It's an indeterminate form. What this means is, so this means we need to basically simplify the function. Okay, and some things that you might try include factoring. Right, a lot of times we'll factor and we'll get something that will cancel out. We could give you a good list here. So factoring, we could find a common denominator if it's some sort of, you know, if it's a complex fraction or if there's 2 terms in the function, you might try putting them together. That might be a good way to simplify it. We could rationalize the numerator or denominator. And earlier we did some rationalizing with conjugates, and this is where that's going to come into play. We have to do the conjugates there. And then sometimes just if you expand, things will cancel. Okay, but again, you only have to try one of these four methods if we get this indeterminate form. Right? If we get a number, you're done. Even if that number is 0. The only problem is if you get 0 divided by 0. That's an issue. Also, another thing that we will get to be aware of is sometimes, and we'll look more at this in the future, but if you get 1 divided by 0 or some constant divided by 0, that is undefined, but it tells you you're going to have a vertical asymptote there. So, and we'll investigate that more. I don't think that should come up tonight or next day or two. But with this one, let's go back and look at this example. Same problem, but this time, let's take the limit as x approaches -2. Okay, so same function, same thing. We get this x approaches -2. So again, we're going to try direct substitution. So -2 squared plus 5 times -2 plus 6, -2 plus 2, and that gives us 0 over 0, right? So it's indeterminate form. So that tells us we have to try something different. We need to try to simplify this function in here. And when it does that, we should be able to, and once you've done that, once you've done one of these things, then you go back to direct substitution, right? That's kind of our one trick, right? Is maybe we simplify it, maybe now it'll work, or maybe now it'll work. So with this one, I would guess most of you see that the numerator is factorable, right? So for this one, the limit as x approaches -2, you get x plus 3, x plus 2, over x plus 2. Those cancel. Right? So this is equal to the limit as x approaches -2 of x plus 3. Now at this point, I'm going to try direct substitution again. Right? I mean, I can do that now. So with direct substitution, we get -2 plus 3, and that's going to equal 1. So this limit would equal 1, would be our answer there. Now, it would be interesting here, and I can't show it on the screen because I'm recording, but if you went ahead here and maybe typed this in your calculator, right? If you graphed this whole function in your calculator, it looks like the line y equals x plus 3. It's just a line. Like it's really that unexciting, but it has some special things going on with it because, so what do we have? X plus 3 So if you look at the graph on your calculator, it just looks like this line if you type this in. But then if you go to trace, and if you type in -2, it does not give you an answer. It just says x equals -2, y equals blank. Because it's plugging it back into this form, and it's getting 0 divided by 0, and the calculator doesn't know what to do with it, so it just doesn't give you an answer. Okay? But this is actually what that graph would look like. So we can see the limit isn't 1. Right? Another trick you can do with your calculator is if it's not giving you a value at -2, try like -1.999 and try -2.001. And you'll see they're both going to be on either side of 1, which will be our answer there. So, and this is again a removable discontinuity. We'll talk more about that. But that's one of the methods that we'll use to solve limits algebraically. We'll look at some of these other pieces tomorrow. I have a worksheet I'll give you here that shows you that you could try some more things.